Probably I can start now screen sharing. So let me check the waiting list. Nobody joining? Okay, good stuff. So where's my share screen? Let's begin immediately. So I'm hoping you can see my screen now. So this is the Python code I've prepared, I put together for you, and I'm happy to share it if anyone is interested. So the talk is about visual exploration and statistical analysis of a diabetes data set using Python. And the plan of attack, or the way I've structured this talk, is in the beginning we're gonna have some basic techniques to explore your data and try and clean it up. And then after that, we'll move on to plotting some useful and informative plots. We'll start with some basic plots, and we'll try to go a little bit complicated, although today it's all basic, nothing too deep today. After that, we'll have a look at some probabilistic analysis that we can do on the data to help us maybe make some predictions or do some forecasting on future events or future cases when we have individuals who come to a clinic and have some measurements made. And after that, we'll have a quick look at a basic machine learning technique called logistic regression, where we'll try to build a model to model the data and then make future predictions. And then we'll have a look whether the probabilistic approach actually agrees with the logistic regression, okay? So that's out of the way. Let's go immediately to the code. This is my code, and I'm hoping we're familiar with Python. If not, don't worry. Python is quite easy to learn, and what I want to get across today mainly is the ideas rather than the actual Python code. So this data set is freely available online. It's made available, and it can be downloaded from different sources, for example, from Kaggle and different sources. I provided details here, if you can see, as you can see, and I'll put this code later on GitHub so you can access it. But I'd like you to imagine this real life situation where you're conducting this study, you're trying to collect some data, and then you want to analyze this data, okay? So this webinar contains several techniques that can be applied to really any type of data. I'm focusing on medical data, but in general, it can be applied to anything. So for this data set, like I said, it's freely available. It's being used as an example in a large number of tutorials and different machine learning techniques and analyses, because it's quite important to always have in mind that whatever technique we develop, we always try to apply it in a useful way. And this data has several columns. One of them, for example, is the number of times the person has been pregnant, or how many pregnancies that person had, 0, 1, or more, whatever it is, the level of glucose, the blood pressure taken at that time, and these are the units, the skin thickness, and these are the units in millimeters, the level of insulin, the BMI, the body mass index of that individual, something called the diabetes pedigree function, which is a function that scores the likelihood of diabetes based on some family history, the age in years, and then an outcome. The outcome will be 0 if that person is non-diabetic, and 1 if that person is diabetic. And normally you'd open data set like this, for example, in Excel or any tabular, basically a platform that gives you the tabular visualization of your data. But what we'll do is we'll try to immediately load it into Python here, and like I said, have a look at some techniques and analyze it and clean it up. So here I'm importing some Python libraries. Like I said, don't worry about the code if you don't know Python. And here what I do is I load the data. It's called diabetes.csv. I mean, if I go here and just show you, what it looks like. So it's, as you see, it's just a tabular data, several columns, pregnancies, glucose level, blood pressure, and so on and so forth. And when you open this in Excel or something like that, it'll be like a proper table, okay? Now, when I load the data, I just read it as a CSV file. We normally prefer CSV files, but with Python, you can read really any format. If it's JSON, if it's even in Excel format, it's fine. So this shouldn't put you off when you see a CSV. If you're not familiar with it, it's fine. It's just a basic textual format. And this is just a peek or a quick look on the top few rows of the table. So we have the pregnancies, glucose level, blood pressure, skin thickness, insulin, BMI, diabetes pedigree, age, and then the outcome. And remember, 1 means that that individual has diabetes, 0 means they're not diabetic. And a quick look even at the few rows tells us that we have some what we call nans or missing values. So perhaps when the data was measured, when the measurements were made and the data was collected, um, some measurements were not made for some reason, data is missing, that person refused to give the measurement, or maybe it dropped while people doing data entry. There's a number of reasons why these things happen. But anyway, we notice that we have some missing data in this column especially. And then we also immediately spot that we have some zero value data. We'll come to that in a minute. So to do some exploration and cleanup, we always try and have a feel and look of our data. So this is something highly recommended whenever you do data analysis. Always have a look at your data, try to explore it, try to see what the contents look like, maybe the units of the measurements, make sure they're all consistent. For example, look at missing values, look at wrong entries. For example, sometimes you have a numeric column like this where the values are supposed to be always numbers, always numeric, right? And then maybe sometimes you can have some text in there by entered by mistake. Always have a look at this stuff. So it's clear that the data has missing or zero values, as we can see. For example, if you look at skin thickness, I mean, no one will have a skin thickness of 0 millimeters, right? So that doesn't make sense. That means there's some error there. That's problematic. And also we have insulin level of NaN, so not available. NaN means basically not a number or something like that. So it's not available. That's also problematic. Sometimes missing values can come in a form of a question mark, so always pay attention to this. And then from there now, you need to decide what to do. But before actually processing this, let's have a look at the contents in a bit more detail of the data. So here we have a table of just a summary table of the data that we have 768 entries. So the data has 768 rows, and these are the columns. Each column, how many available entries, so how many non-null entries, and then the data type. So it's numeric, integer, float, integer, and so on and so forth. And sorry, sometimes I pause because some people actually want to join. So now if a pregnancy, glucose, blood pressure, you notice the insulin, for example, remember the data has 768 entries, but with the insulin, the non-null values are less than 400. That means that column has a large number of missing values, okay? Probably about 50% or slightly less than 50% are missing. So here you need to decide what to do with this column. Do you drop it, just remove it? What to do is really up to you. I'll show you a couple of techniques, but this is really up to you. But this is a good way to actually have a summary about your data, what's available, what's not. And then in Python, this is, by the way, a package called pandas in Python, this package here. We have another function that's useful called describe, and this will give us a statistical numeric summary of all the numeric columns in your data. So remember, this works only on numeric columns. It gives you the count, how many values are available, give you the mean value, standard deviation, the minimum, the 20%, 25% quartile, 50% quartile, 75% quartile, and then the maximum value. So this is a really good summary for you to look at and make sure, for example, the data makes sense. So for example, pregnancies, sometimes 0 pregnancies, that's fine, it's expected. Glucose level, is it actually within the normal range? I don't know whether we have medical doctors here with us today. They will tell us whether this is within the normal range. Blood pressure, for example, somebody has blood pressure of 0, that's the minimum value, 0. Does that make sense or not? I think no. Skin thickness, like we said before, 0 skin thickness, that doesn't make sense. The insulin, again, a large number of missing values, BMI, and so on and so forth, right? So what do we do with the missing and 0 values? This is up to you. You decide what to do here. So sometimes you want to drop them. So for me, for example, if you ask me the insulin, nearly half of it is missing. That means I'm going to drop that column immediately, right away. Okay, and remember that sometimes missing data comes in a form of question mark rather than just empty. So you need to deal with it, pay attention to it. So what I do here is I show you a simple code to replace that question mark with a NaN, and then later on we can deal with that NaN, right? And in this little code here, what I do is I just count how many missing values I want. In the beginning, I count how many columns have missing values. So here it tells me that 3 columns have missing values, and then here I count for each columns how many missing values do we have. So pregnancies, it's full, 0 missing values. Glucose, we have 5 missing values. Insulin, 300 and something missing values. BMI 11. So like I said, immediately for me, for example, I'd like to drop insulin because nearly half of it is missing. So just drop that column. We don't need it anymore. And then after I drop the full column, what I do is I say, okay, let me drop the rows that have missing values now, because now I have 5 in glucose and 11 in BMI, and there might be some overlap between them. Let me drop those rows. Some of you might say, no, I don't want to drop those rows. What I'd like to do rather is maybe replace the missing values with something meaningful. So sometimes what people do is they can replace it with the mean of that column, and this is what I do here. This code does that for you here. I commented that just for you to be aware of it. And the mean, for those of us who don't remember it, it's the mathematical average of your values, or you can also replace it with the median. The median is the middle number in it. When you sort your values in ascending or descending order, you take the middle value, and that's the median. And to replace the missing value with the median or the mean in Python pandas is just as simple as this line here, okay? Another step I do here is I said to myself, well, because I have some columns have some zero values. If I go back up here, some of them have zero values, and in many cases that doesn't make sense. So, okay, the outcome, it's 1 or 0, that makes sense. And the number of pregnancies, we can have 0 pregnancies, for example, for that individual. But for the skin thickness or for the BMI or the blood pressure to be 0, that doesn't make sense. So what I'm going to do now is I'm going to drop any row that contains 0 in one of these columns: glucose, blood pressure, skin thickness, BMI, diabetes, pedigree function, or age. If any of them has 0 value, I'm going to drop that row, completely, okay? So if you notice now, the number of rows I have after I've dropped the NA values and the insulin column is 752. This is after 768. And this one line here does what I just told you, which is to remove any row that contains 0 for any of the columns except the pregnancies and the outcome. When I drop those rows, I end up with 532 rows, okay, in my data. And remember now, some of them are diabetic, for diabetic individuals, some of them are not. And now we can have a look at some summary information. I have a little code here for me to be able to display tables in a proper way. So when I run this code, you see my table now has the edges and the borders, which is much better when you visualize it. And what I'm going to do here is, because I have my outcome now is 1 or 0, I'm going to group my data according to the outcome. So when the outcome is 0, meaning for individuals who are non-diabetic, give me a summary of that data. And then when the outcome is 1, for the individuals who are diabetic, give me a summary of that data. When I run that, again, just quick look at this graph. Now the values will change a bit because we dropped some data. And now when I do this group by, I group by the outcome, like I said, and then compute some basic statistic like the mean, for example. When the outcome is 0, the average pregnancies is 2.9. When the outcome is 1, the average pregnancy is 4.7. So you notice maybe, for example, that for people who have diabetes, the number of pregnancies seems to be slightly more than people who don't have diabetes. Same thing for glucose level, which makes sense. The average glucose level for people who are diabetic is more than those who are not. Same thing for blood pressure, the skin thickness, the BMI. People seem to have more weight, people with diabetes. And then in average, they seem to be a bit older than the ones who are not diabetic. This is a nice visualization of the mean and the median of your data. So when you have a numeric value and you try to have what we call a histogram or a PDF probability density function that describes your data, we're always looking for this bell-shaped or normal distribution shape for our data. When the mean equals the median, that's the perfect situation. When the mean is larger than the median, I see on this horizontal line here, so the mean is larger than the median, when we go from left to right, then our data is right skewed. When the mean is less than the median, then our data is basically left skewed. And like I said, the perfect situation is when the mean equals the median. And the difference between the mean and the median tells us about our data, as you can see, whether skewed to the right or to the left. Okay, so I can have more detail now by grouping the data by the outcome and then computing the mean and the median. And you can see for pregnancies, you have the mean and median. Like I said, for people who are diabetic, which is the outcome equals 1, they seem to have more pregnancies and a higher level of glucose, higher level of blood pressure in general, seem to be older. You can look at the data now and it gives you just a general overview of what your data looks like. with this stuff, I'm gonna stop the first part, or I'm sorry, end the first part of this webinar, which is just to load the data, try and explore it, and try to clean it up. So we've gone through loading the data, displaying it, dealing with missing values, whatever you want to do with them, with the columns or with the rows, remove them, keep them, replace them by mean, by the median, by something else. Look at the zero values, for example, do they make sense or not? Always pay attention to the fact that in many situations, missing data comes in the form of question mark rather than empty cells in our data. All these kind of situations are possible in real life. I deal with this in a daily basis, so I can tell you, you can trust me that this is basically a typical situation in our day-to-day life when we deal with data. Okay, so that's the end of the first part.